The name of our project is Electric Water. What we're going to do is we're going to build a water wheel to demonstrate hydroelectric power. The first thing we did was lay out all of our materials on the table just to see what we were working with. We have the water wheel, the generator, the electric meters, the base, the straps, the screws, the scissors, the drills. And our challenge was to take all of this and turn it into this. So we asked our construction expert, Adam, if he wouldn't mind helping us out. Here we see him making preparations to attach the water wheel to the generator. This is very high strength industrial glue called epoxy. And what you have to do is you have to mix these two parts together in order to activate the glue. He's got to be real careful not to get any epoxy on his hands because it sets up real quick. Next we attach the generator to the water wheel by sticking the end right in the epoxy. We realized this was going to take a minute. So we created some shims to hold the generator while the glue dried. While we were waiting, we decided to enlist the help of our resident physics expert, Dr. McIsaac, to help us understand how to measure the efficiency of our water wheel. And what we ended up with was our energy input formula and our energy output formula. But before we could get into any calculations, we had to take some measurements. Here we were measuring our water flow. We filled up a flask with 700 milliliters of water in just under 6 seconds. Then we made sure that our wiring was correct. And we wanted to make sure everything was going to run smoothly. So we took a water wheel that was already in the lab and we set it up as a dry run just to make sure everything was going to work out. Once we saw that we were getting some readings, it was time to see if our water wheel was going to crash and burn or if it was going to work out. So what's happening here is the force of the water is spinning the water wheel, which in turn spins the coils inside the generator, which interact with the magnets, and it sends an electrical current through the wires to the meters. Now that we have the data, we can use that to measure the efficiency of our water wheel. So now it's time to go to the drawing board. So we start with our original formula, which is going to give us our energy input and our energy output. And then we plug in our data, and after a little bit of a fight with the calculator, we end up with our energy in at 0.171 watts and our energy out at 0.0289 watts for a total efficiency rate of 17%. Or really the easiest way to look at this is just a simple giver-receiver diagram. When the water falls and hits the paddles, there's a decrease in the kinetic energy of the water. That increases the kinetic energy of the generator paddles, thereby increasing the electromagnetic energy of the coils inside the generator. And that's how a water wheel works.